Hello everyone, in this lecture we are going to discuss solving polynomial inequalities. We have a cubic inequality here. X cubed minus 5x squared plus 2x plus 8 is greater than or equal to 0, and we want to find out values of x that would satisfy this inequality. So clearly we wish that this cubic polynomial was given in factored form, but it is not. So we need to factor it. How do you factor it? We use our knowledge of factoring, that is factor theorem. So the roots of the divisors of 8 are plus minus 1, plus minus 2, and we have 8 candidates that may make this f of x, if I call this f of x, be equal to 0. So we're going to try different values, and we're going to try f at 2. So it's 2 cubed minus 5 plus 4, and luckily we end up with 0. So this means that obviously x minus 2 is a factor of f of x, or f of x is divisible by x minus 2, basically. That's the meaning of it, okay? So now, what we're going to do, we're going to divide. We're going to divide the cubic polynomial, okay, by, we're going to divide it by x minus 2. But long division is like time consuming. I'm not saying you can't use it, but it's going to take a long time. Therefore, we are going to use the synthetic division, which is quite faster. The root of the divisor is 2. 1 times 2, 2, add them up 3, times 2, negative 6, add them up 4, and then negative 8, add them up 0. So this is the remainder of 0. And now we have x squared minus 3x minus 4 as our quotient, okay? So f of x basically can be rewritten as x minus 2 times x squared minus 3x minus 4. We always try to see if we can fully factor. So this quadratic trinomial perhaps is factorable. Two numbers add up to negative 3 with a product of negative 4. Perhaps we can find such two numbers. I say 4 and 1. So 4 times 1, so negative 4 plus 3. So we see that negative 4 and 1 add up to negative 3. Negative 4 and 1 add up to negative 3. And negative 4 times 1 is negative 4, so it works, okay? So we fully factored this cubic polynomial. Now, we just have to remember that this is supposed to be greater than or equal to 0, right? Okay, so instead of 2 factors, like in quadratic inequalities, now we have 3 factors, so the inequality becomes more complicated, because I have to find out over what interval this expression is positive, over what interval this one is positive or negative, over what interval the other one is positive or negative, and then find out over what sort of common interval the product would be positive. Very difficult. That's why we are going to construct a chart. Okay, we're going to use this so-called chart method. So we have x, of course, from negative infinity up to positive infinity. It may vary. The factors we have are x minus 2, x plus 1, x minus 4, and the last row is f of x, which is the product of these factors. So we have all these rows in our chart, and we are going to find the roots of each factor. So if you set each factor equal to 0, you can easily find the root of that factor. So we have 2, negative 1, and 4. From the least to the greatest, we are going to sort them and include in our charts. So negative 1 goes first, and then 2, and then 4. So now we have different intervals in the form of a chart, and we're going to take care of zeros first, like in the past. So x minus 2 is 0 at 2, x plus 1 is 0 at negative 1, x minus 4 is 0 add 4, and if any of these factors is 0, then it will make the whole product to be 0, which means that f of x would be 0 at any of those numbers. Then we determine the plus minus sign of each factor. So x minus 2 has a positive sign if x is greater than 2. For example, if x is 3, or like 4 or 5 or 4.5 or whatever. But if x is less than 2, such as 1.5, then 1.5 minus 2 has a negative value. So x minus 2 will have a negative sign if x is less than 2. Regarding x plus 1, we have positive on the right side, negative on the left side. Okay, for the same reason. X minus 4 is positive if x is greater than 4, obviously. And then it's negative if x is less than 4. So now if you find the product of these first column signs, negative times negative is positive, positive times negative is negative. Negative times positive is negative, negative times negative is positive. So we get negative and positive right there. So using this nice, excellent chart method, we could easily find out the plus minus sign of this whole product over different intervals. That's a big deal, I say. Now, we want this cubic polynomial to be positive, greater than or equal to 0, means positive. So that means the negative parts are not in the game, so we don't care about the negative parts, okay? So I just throw them away, I shade them away, and I only take care of parts where f of x is positive, because that's what we want to find, okay? So I'm going to say if x is between -1 and 2, or if it's greater than 4, then this would happen. I mean, f of x would be positive, okay? So I'm going to say x is greater than or equal to -1, or less than or equal to 2, or x is greater than or equal to 4, okay? So if x is greater than or equal to 4, or x is in between -1 and 2 inclusive, any real number within that interval will be the solution to this polynomial inequality, and it would satisfy this inequality actually. So here we have -1 and 2, so that's -1 and this is 2. I'm just drawing the graph of the solution set, and the reason why I am drawing solid dots instead of holes or empty circles is because -1 and 2, the equality cases must be taken into account, because the question says the cubic polynomial must be greater than or equal to 0. It doesn't say strictly greater than. And x greater than 4 would be this part here. Any real number greater than 4 is okay. So this becomes the graph of the solution set. So that's the chart. This is the solution set final answer, and this is the graph of the solution set. And this is the work that we showed, how we factored and how we proceeded from there. Now, using graphical method, you can also find the same answers, believe it or not. So here is the graph of that cubic polynomial, okay? If you draw the graph of this function using table of values or any other method, maybe sketching or whatever, you would end up with a graph like this with 2 turning points, okay? Now, what are the x-intercepts? -1, 2, 4. Watch here, -1, 2, 4. These are the x-intercepts, okay? Now, we want this polynomial, f of x, to be greater than 0. Now, start thinking a little bit for a second. F of x is greater than 0 or positive where? Whenever the graph is above the x-axis, because otherwise, below the x-axis, f of x is negative. So this part that is above the x-axis, this part, f of x is greater than 0, okay, all the way up to here, and then the graph goes below the x-axis in the negative region. That doesn't count. And then after 4 again, it goes up just like that, okay? So as you clearly see, wherever the graph is red, or darkened, then that is the interval or over which f of x, okay, is greater than or equal to 0. It's either 0 on the x-axis, or it's positive above the x-axis. So by graphing, you can find those intervals easily. You can say x is between -1 and 2, or x is greater than 4, where the graph is above the x-axis. So that's just a graphical solution, okay? If you have access to the graph or in whatever question, depending on the situation. But this other method is the algebraic method, okay? You need to know the algebraic method in and out, and this one, I just explained it as a bonus, okay? So I hope you learned how to solve polynomial inequalities. If this is a quartic polynomial or any other type, it's okay. You're going to solve it in a similar way. You're going to factor it using any method you want, maybe using factor theorem or whatever method, and then you find the solution set. You graph the solution set just to visualize, the solution, and you show your work by constructing the chart. Thank you, and keep practicing.